Howdy, Huskies. Welcome to Chapter 2 of your pre-calc review. This one's going to be a little bit longer because there was a lot more aspects to Chapter 2. It was all about solving for our polynomials. And so the first thing that you want to do is you want to realize what you're dealing with. And so basically when we did this, we have an x squared, which was our parabolas, and then everything else. So in this first one, we do have, in our first couple examples, I should say, we should have parabolas. So there are there's some rules we generally use before those that don't apply to polynomials, which is basically x cubed and up. We refer to those as polynomials. So our first one is an x squared, so it is a parabola. Now when you're solving, you're looking for roots, answers, solutions, or zeros. They're all the same thing. You're looking for where it crosses the x-axis. So you could get a graphing calculator and go ahead and find out where those values are, or you could just go ahead and go through the factoring process. So to start, we would use an x, and we would take our a term times our c term. So a times c is going to go here on the top, which is 4. And then our b term is going to go down here. So let me rewrite this so we can see this so you can follow along with what I'm saying. So what's going to go here is a times c, and then our b is down there. So we're looking for the numbers that multiply to 4 and add to a -1. Well, the factors, ladies and gentlemen, of 4 is going to be 1 and 4, and then 2 and 2. So I don't have those values to work that are going to make this work. So when that happens, we had to shift gears into our quadratic formula. So anytime something doesn't factor, you have to do the quadratic formula, negative b plus or minus b squared minus 4ac all over 2a. So you're going to use the same a's, b's, and c's as in standard form that you can see on number 6, and we're just going to plug it in. So my b is actually a -1, so this is going to be a negative of -1 plus or minus -1 squared minus 4. A is 4, c is 1, all over 2a, so 2 times 4. So order of operations says that we have to do this square root first, because square roots are technically exponents. So I'm just going to do this negative and negative, make a positive to make my life easier anyways. So then -1 squared is 1, and then minus 16 all over 8. And then we're continuing to do inside that radical here. So that's going to give us a 1 plus or minus a -15. I don't know where I wrote 115. It's kind of crazy. All right, anytime you have a radical, ladies and gentlemen, and you have a negative inside of it, that's imaginary. So the imaginary unit, so again, this is imaginary. And so to count for that, we're going to go ahead and use the imaginary unit I. So this is going to be 1 plus or minus I root 15 divided by 8. And so that is our answer. Just a couple of things you want to notice, that this is a plus or minus. That means that those are 2 answers. And sorry, it flipped there. And when you do this example, and you graph it, you're going to note that it doesn't cross the x-axis because it's above it. So that's why even if you tried to graph this one, it wouldn't work. Alrighty, so let's go to the next one. So when we go ahead and we did the video on this, we told you that your vertex is going to be an x and a y. So how do we find that vertex point? Again, the vertex point for this parabola, I should draw it going down, because it does indeed go down, because this is a -2. That tells me it goes down. So how to find that, we're going to do negative b over 2a for our x, and then we're going to plug that in. So I'm going to say f of negative b over 2a. So that is going to be our formula that we used, which is basically saying, hey, take my A, B, and C because it's in standard form. Do x is equal to negative b over 2a. So that's negative of negative 4. And then we have a 2a, so 2 times negative 2. So that's going to be 4 divided by a negative 4, which is going to go ahead and be a negative 1. So we know that this negative b over 2a is a negative 1. So to find our y, we just have to plug it back in to the original equation. So y is equal to negative 2 times negative 1 squared minus 4 times negative 1 minus 7. So order of operations, say I got to do this negative 2, or sorry, the negative 1 squared. So that's going to give me 1 times negative 2 is going to be negative 2. And then plus 4, and then minus 7. So if we look at this, I'm going to have a negative, I believe, 5. Looks good. So then a negative 5, there's going to be my vertex. Boom shakalaka. So our next one here, B, if you want to go ahead and hit the pause button and give this a shot, it's going to be a little bit saucier. With our algebra, you're going to get 2 fractions. But let's see how you did. So again, we're going to go A, B, C. That's an x. C. So x is equal to negative b over 2a. So that's a negative 20 over 2 times 6. So that's negative 20 over 12. And then we could reduce all those by 4. So divide by 4 to reduce. So negative 5 thirds. All right, so we got to plug in a fraction. Not ideal, but those things happen. So our y is going to be 6 times negative 5 thirds. Excuse me. Let's make sure it's a negative of a negative, so this should be a positive. There we go. Because it's negative b and it's a negative 20. So that's going to be positive, positive. All right. Always want to check your answer as you're going when you're making your instructional video to make sure you don't make a silly thing like a sign, make you have to do the whole thing over again, like I've done a million times, I feel like, throughout the course of the semester here. So when you have a parentheses squared, you should write it twice, but this is a monomial, so you can just go ahead and square the top and the bottom. So it's going to be 625 over 9 minus 20. We'll say this is 100 thirds plus 3. So that's going to be 120. Let's go ahead and do our cross canceling. So I can reduce this. So 3 can go into 6 twice. 3 can go into 9 3 times. So really this is going to be a 2. So this will be 50 thirds minus 100 thirds plus 9 thirds. It's going to be negative 41 thirds. So our vertex here is 5 thirds and then negative 41 thirds. Alrighty. So in both of these cases, if we look at these, those were what's called standard form, and that's when everything is unpacked. You don't see any parentheses or anything like that. I was going to say there's 2 parentheses forms. So that's why we did the negative b over 2a. There are different ways to do this when it's in a different form. And we're going to kind of see those different forms here creep up on 8. So this is what we call vertex form. Okay. So this is still a parabola. So you have 2 options. You can unpack this and find the vertex. Okay. So by unpacking, that means you'll do this, which some might actually think is probably easier. So that will be negative 15 and then minus 3x minus 10x and then plus 2x squared. So this would be 2x squared minus 13x minus 15. And then you could do the exact same thing that we just did on the top. However, since we're trying to give you a different strategies here, to see how this works. Ladies and gents, this is technically going to be what's known as intercept form. So the minimum value is your y coordinate of your vertex. So we can use x is equal to p plus q divided by 2. And so what those p and q's are your zeros. So your p is going to be when that equals 0, and your q is when this equals 0. So ladies and gents, I'm going to pick up right here because I'm not going to lie, I did the whole problem with screwing up my fractions. So welcome back, and sorry. Thankfully, I just didn't go back and try to change it. I just went and tried to edit the video. So again, we're setting these equal to 0. So 3 minus 2x is equal to 0. So I'm going to bring that over, and I'm going to get negative 2x is equal to 3. And then when I divide by a negative 2, we're going to get x is equal to 3 halves. When I bring that over, that's a negative 3 halves. There we go. Almost made the exact same mistake again. Good Lord. Alrighty, on our next one here. So again, we just set this equal to 0, found one of the zeros, which was 3 halves. Going to do the same thing over here. So 5 minus x is equal to 0. So 5 is equal to x. So we have our two values. Okay, so now we're going to go ahead and plug them in to this p over q divided by 2. So it's going to be 3 halves plus 5 divided by 2. So this is going to be 3 over 2 plus 10 over 2. So that's going to be 13 halves, all that divided by 2. So 13 divided by 2 times 1 half when I do the divided by 2. And that's going to give us 13 fourths, which is great, but that's not what we're looking for. We are looking for the y value, which is going to be our minimum here. So I got to plug it back in up here. So again, like I said, this is just a different strategy. If you like the standard position first, you do that. So 3 minus 2 times 13 fourths, and then 5 minus 13 fourths. So this is going to give me 3 minus 13 halves. And then we'll make this a common denominator, 20 fourths minus 13 fourths. So we're going to go ahead and get 6 halves minus 13 halves. And then this is going to give me 7 fourths. Getting a little bit tough to read there, but we're going to get negative 7 halves times 7 fourths. And so we're going to get negative 49 eighths. So, ladies and gentlemen, that is our answer right there. Took a little bit of fractions in there, but that's not the worst thing. Again, you could have done this by using this exact way we did it before, except you were just going to be looking for this part. So, it's up to you. Alrighty, let's go ahead and erase this so I have some space here for the next one. If you need to go back and watch the previous part, you can do that. So this one, we're going to set each one of these equal to 0. So 1 minus x is equal to 0, so x equals 1. And then 8 plus 3x is equal to 0, so 3x is equal to a negative 8, so x is negative 8 thirds. Oh, this is going to be fun already, I can tell. So we're going to do our p plus q divided by 2, which is our x. So 1 plus a negative 8 thirds. All over 2. So let's get a common denominator. So 3 thirds minus 8 thirds divided by 2. That's going to give me negative 5 thirds divided by 2, which is going to be negative 5 thirds times 1 half, which is going to be negative 5 sixths. All right, so this, again, this was all x. Notice that's what we started with. So now I got to plug it back in to find my y. So 1 minus a negative 5/6. And then we're going to have 8 plus 3 times a negative 5/6. All right, now I'm going to erase all this just because I want to make sure that I have enough room here. So a negative and negative are going to make a positive, so 1 plus 5/6. And then we'll do 6/6 plus 5/6. So that's going to be 11/6 for our first fraction. So for our second fraction here, we'll do this part here. So that's 3/1 times negative 5/6. So that's negative 15/6, which is going to be a negative 5/2 when I divide both of these by 3 here. So we're going to get 8 and then minus 5/2. So let's get a common denominator. So 16/2 minus 5/2 is going to be 11/2. All right, looks good. And so then we'll multiply across, and I'm going to get 121/12. And that is our value right there. Let me check my answers to make sure that I did this right. Looks good. So we can move on to our next example. All right. So end behavior. So end behavior, ladies and gentlemen, boys and girls, are basically where are your arrows when it leaves the graph. Okay. So in this case, if I look to what we have, it's all about knowing how many zeros you have. So I'm going to have 3 zeros here. I'm going to have another 3 zeros there. And then I'm going to give you 1 0. So my total zeros is going to be 7. Okay. So that's going to tell me an awful lot. Okay. Because the first thing you start when you do your end behavior is it an even number of zeros or is it an odd number of zeros? So obviously this is an odd. So if it's odd, it's going to look something like this, or it's going to go down like this. So then I look at what your leading coefficient is. So this is a 2, and when I multiply all this out, because the 2 is positive, this is going to be our graph. This is when obviously that leading coefficient is negative. So if I look at this, this is going to go down and then up. So that would be positive. So let's write our end behavior. So on the left, when x approaches negative infinity, my arrow is pointing down. So my f of x goes to negative infinity. And then when it's going to the right, when f of x is positive infinity, my arrow is going up, so that f of x is going to positive infinity. And that is our answer right there. Now, if it was an even function, then it would be going up, both go up if they're positive, or they both going down if they're negative. So that's why we care about the number of zeros, is it tells us right off the bat what the graph's going to look like. All right. Alrighty, then we have B here. So let's go ahead and find the number of zeros. So this is going to be 41 right there, 3 right there, 5 right there. So if we add both of those together, it looks like we're going to go ahead and have an odd number because it's 49 again. So just like what we saw, it's going to look like this. Just a lot more bumps along the way. Alrighty. So again, I have to look at this. Is this a positive or negative? Well, this is a negative. So that means my graph is going to look like this. So on the left-hand side, that left-hand arrow there is in pink, that's going up. So x approaches negative infinity, which means the left. The arrow's pointing up, so f of x goes to positive infinity. And then this is my right-hand side. When x goes to positive infinity, my f of x is going down. So that's negative infinity. And there's our end behavior. Nice and easy peasy lemon squeezy. All right. So ladies and gentlemen, we'll go ahead and find our zeros. So as I mentioned previously here, sports fans, you can find your zeros by where it crosses the x-axis. So technically, you can go ahead and put this in the graphing calculator and see what you have. I'm going to do it the old algebra way. So the first thing you're going to do is do what's called your P over Q's. Then you want to do your synthetic division. And the key with that synthetic division is your remainder needs to be 0 for it to work. And then once you're at an x squared, so once you're at x squared, you're just going to factor. All right. So again, this is going to be the way we're going to go ahead and get this party started. So P over Q's. So this is my constant, aka my P, and this is my leading coefficient, aka my Q. So what are the factors? So the first thing we need is our factors. So for 8, those are going to be 1 and 8, 2 and 4. So the factors of 8 are 1, 2, 4, and 8. So for my leading coefficient, it's just a 1. So that's going to be 1 times 1, which is just going to be 1. So again, it's P over Q. So I'm going to take all these P's and put them all over my Q's. Now, the good news is it's just a 1. So P over Q, the idea is that it's just going to be exactly what they are. So my list of zeros, or my possible answers, are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So I have 8 possibilities here, again, because they're plus or minus. But what I want you to note is that's an x cube. So that means I have 3 answers. All right. So what we're going to do now is we're going to do our synthetic division, which is that L. So you're going to put your leading coefficients. So 1, -1, -10, and -8 right there. And then you're going to put any one of these P over Q's on the outside to see if it works. So ladies and gentlemen, boys and girls, let's start with 1. 1 is not going to work, but I just want to show you. So bring that down. That's a 1. 1 times 1 is 1. That's going to make it 0. 1 times 1 is going to be 0. That's a -10. And so this is going to be a -10, and that's a -18. This is our remainder. It's not 0, so it's not going to work. Okay, so let's try another one, like -1. This one, I believe, is going to work. So drop the first one. You're going to always add down. And then you're going to multiply the outsides. So since the 1 didn't have anything underneath it, that's why I just dropped. So times the -1 is going to be -1. So that's going to give me a -2. And then -1 times -2 is going to give me a +2. That's going to give me a -8. And then I'm going to have -1 times a -8. And that's going to be a +8. And then I have a remainder of 0, which is what I want. So this is the remainder. It always is the remainder. And then you go up in order. So the first one's going to be a no x. Then it's an x to the 1. And then an x squared. So this is really x squared minus 2x minus 8. So since this is an x squared and you can factor it, now we're good to go. That's what this third step is if you're not at x squared, you'll have to do another synthetic division to finally get to x squared. So we'll go ahead and do our x. What numbers multiply to a -8? Add to a -2. That's going to be 4 that's negative, 2 that's positive. So this is going to give us x minus 4. X plus 2 is equal to 0. So x minus 4 is equal to 0. X plus 2 is equal to 0. So x equals 4 and x equals -2. And then we got to bring down our answer that we used in our synthetic division. And then we have our 3 answers. Again, it's an x cubed, so that means 3 answers. And that's what we have down there. Excellent. So ladies and gents, boys and girls, we'll move on to the next one. It says how many turning points that you have. Now, it says the maximum number of turning points, so that doesn't mean that you graph it and you find it. It basically just means that you need to know how many zeros you have again. So this is 4, this is 3, and this is 1. Again, you know this because of the exponents. So that means I have a total of 8. So at most, it's going to be basically zeros, I should say your total zeros minus 1. So 8 minus 1 is going to give us 7. So that's the answer to number 11. Alrighty. So we're going to divide. My rule about dividing polynomials is if this is just a 1x, you get to use synthetic division. If it's anything else, you're going to use long division. So we're going to use long division here on this one. So 3x minus 2. And then inside is going to be 9x squared plus 3x minus 1. So when you're doing this, you're just caring about this 3x. That is going to be your kicker. And then the easiest way for my brain to think about this is how do I make that 3x into a 9x squared? Well, I would multiply by 3, and it needs another x. So that's the first part. So now we're going to go ahead and multiply down to this one. So it's going to be 9x squared and then minus 6x. So just like we did when you were way back in the day doing long division, you're always subtracting. So this is where this gets a little bit tricky, but you have to think of it almost as like one piece at a time. So let's do this first one. So this is really a 9x squared minus 9x squared, which is just going to be 0, which is what you want, okay? And then in the next one, we'll highlight this one in pink here. This is where the negatives get a little tricky, so you got to really watch. So 3x minus a negative 6x is going to give us 9x. And then you're going to drop this down to become minus 1. So now we're going to say, okay, I have a 9x right here. How do I make this 3x look like that 9x? Well, I need another 3. So then I'm going to multiply, so I get 9x minus 6. So the first terms are going to cancel, because they always should be, because they're the same number. And then I'm going to have a negative 1 minus 6. So let's rewrite this over here. Negative 1 minus a negative 6. And so that's going to be negative 1 plus 6, which is going to be 5. So that, because this degree, because technically this is an x to the 0, so since this is less, this x to the 0 is less than this 3x to the 1, this is going to be your remainder, and you're going to stop. So it's going to be 3x plus 3, which is what we got on the top here. And then we're going to do our remainder. So plus, it's always plus, and then your remainder over your divisor. So just making sure that I did this one correctly. Looks like we got the right answer. So life is good to go. So again, we did this way because this wasn't just a 1x. So on number 13, it is a 1x. So I can do our synthetic division, which is going to be a lot faster. You can do long division if you want to, but I'm going to set this equal to 0. And so I get x equals 3. So I'm going to put a 3 on the outside, and then all my coefficients, so 2, negative 5, 1, and negative 2, on the inside. 2, negative 5, 1, negative 2. And remember, you're always going to add down and multiply across. So since there's nothing to do with this first 2, it just drops. So 3 times 2 is 6, and then 6 goes into 10. I don't know where 6 went into 10 for. Good Lord. Negative 5 plus 6 is going to give me 1. So 3 times 1 is going to give me 3. Add down, that's 4. 3 times 4 is going to give me 12. And then when I add down, that's a 10. So it goes remainder, the no x, which is your constant, your x to the 1, and your x squared. Now, we're not going to write the whole thing out because it just simply asks for what is your remainder. Well, what is our remainder? If we look down here, our remainder is just 10. So that's our answer. Easy peasy. Alrighty, number 14. It says, if 2 is a 0 to the function, find these other 2 zeros. Well, sweet, they gave us one of the zeros. So this actually means there's no need for P over Q because we have it. We're all set to go. And again, it's an x cubed, so that's why there's 3 answers. So I'm going to put a 2 right here because that's the one we're going to divide out. And then all my leading coefficients, just like we did before. So we should get 1, 2, negative 29, and 42. We're going to add down, so I just dropped the 1. 2 times 1 is 2. That's going to give me 4. 2 times 4 is going to give me 8. That's going to be a negative 21. and then 2 times negative 21 is a negative 42, which is 0. Now, you should always have this remainder of 0 if you did things correctly, because that means it goes into it evenly. So this is the no x, this is an x to the 1, this is an x squared, so this turns into x squared plus 4x minus 21. So because it's an x squared, we can just factor it. So what numbers multiply to a negative 21? Add to 4, that's 7, and a negative 3. So we're going to get x plus 7, x minus 3 is equal to 0. Set each one of them equal to 0. So x plus 7 is equal to 0, x minus 3 is equal to 0. So x equals negative 7, and x equals 3. So we found our other two zeros, because it says, what are the other two zeros? Now in total, it's 3 with the 2 that we had at the start. So making sure I got my answers right, it looks like I'm good. So let's move on to our next one. So at number 15, we're moving on from this part, and we're going to go ahead and find our asymptotes, okay? So the first thing that you always want to do is you always want to find your vertical asymptotes. And your vertical asymptotes are when and it's always your denominator equal to 0. So with your denominator equal to 0, that's an important fact to note. But ladies and gents, this case, it's not asking for that. It's looking for your horizontal asymptotes. So ladies and gents, there was 3 cases for our horizontal asymptotes. There was top heavy when they were the same, and then they were bottom heavy. And that was all basically your degrees. So in this case, ladies and gentlemen, boys and girls, we are the same because it's an x squared on top and an x squared on top. So they have the same degree. So when they are the same degree, your horizontal asymptote is you're going to take your leading coefficients and reduce. So my leading coefficient on the top is a 6. Leading coefficient on the bottom is a 2. Reduce that, I'm going to get a 3. Now there's other 2 rules. There's the top and the bottom. I would recommend you going, if you don't remember those rules, to go back and take a look at those videos to remind yourself. Alrighty. All right, so our last few here are solving inequalities. When you're solving these, it's very similar to the ways you've done in the past. The idea is just go ahead and solve them by any means that you would normally do, and then go back and check, because you're going to have regions that work. So I'm going to set this equal to 0. So 3x squared minus 4x, and then minus 4 is equal to 0. So I should say greater than 0. But I'm going to solve it as if it's equal to 0. So to factor, what numbers are going to be 3 times negative 4? That's a negative 12, and add to a negative 4. That's 6 and 2, the 6 being negative. So 3x squared minus 6x plus 2x minus 4. We're going to factor this by grouping, which means I factor the first 2, taking out a GCF, which is a 3x. So we get 3x. And then x minus 2. Over here, I'm going to take out a 2. So I should get 2x minus 2. Notice these parentheses are the same. So we're going to get a 3x minus 2. And then we're going to get an x minus 2. Sorry, 3x plus 2, because that's a positive 2 right there. And then an x minus 2. Then we're going to set those equal to 0. So 3x plus 2 is equal to 0. And then x minus 2 is equal to 0. So 3x is equal to negative 2. So x is going to be negative 2/3. And then x equals 2. So now that we have our zeros, we can kind of go ahead and find what's going on. The idea is you're going to go ahead and check it, because I have ranges. So I have 2 zeros, so 2 tick marks. So negative 2/3 and then 2. So we want to find out when it's true and when it's false, because that's going to satisfy this inequality. So pick numbers that work, and then use your calculator to make this really easy, okay? And again, I'm going to plug it in to this one right here just to make things easier. So let's try a negative 6 a 0, and then a positive 6, just for consistency. So I'm going to have positive 3 times a negative 6 squared minus 4 times a negative 6 minus 4, and again, that has to be bigger than 0. So this is going to be negative 6 squared is going to be 36 times 3 is going to be 108 plus 24 minus 4. You don't even have to do the math to realize that that's true. Okay, that's clearly going to be bigger than 0. So let's try the middle one, which is 0. So 3 times 0 squared minus 4 times 0 minus 4. So 0 minus 0 minus 4. Is that greater than 0? Absolutely no. So that's false. And then so we'll go ahead and do our last one here, which should be pretty much the same here, because when we square the 36, we're still going to get a very big number. So 108 minus 24 minus 4 is still true. All righty. So if I look at this, I'm going to erase this now. So now I'm going to write my answer. I know that it's true up until that point, and it's true past that point. And the reason is because it's not equal to. So when I'm pointing to the left, that's negative infinity to negative 2/3. It does not include those values, so parentheses. And then from 6 to positive infinity, because that arrow is going that way, so positive infinity. And then we put a U in the between for union, as in it's one or the other, because it can't be in both places. Sorry, where did I put the 6? Lord, 2. Yeah. Don't put the tester points. Plug in these zeros. I almost made a mistake. And then, of course, I checked my answer and then went, whoa, you did all that work right just to write the wrong answer. Way to go, Mr. Naughton. All right. So 16 is going to be the exact same process, except we're going to have to solve this, have 3 zeros, and then have multiple spots where we're going to have to check this. All righty. So it's already set equal to 0, so that's kind of good. So unfortunately, they don't give us the value, so we're going to have to do our P over Q's. So this is my P, this is my Q. So the P's are going to be obviously 1 and 6 and 2 and 3. And then my Q is 1. So my list of possibilities is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And you're going to play this fun game until you, our L game, until we find our remainder of 0. But since I don't want to spend all day on this video, we're going to go straight to an answer that works. So if I look right here on my answer sheet, I believe 1 works. So 1, -2, -5, and 6. Those come from your coefficients in front here. So remember, you add down, so we drop because there's nothing to add with. So that's a 1. Multiply diagonally, so 1 times 1 is 1. Add down, that's a -1. That's going to give me a -1 right there. That's going to give me a -6. That's going to give me a -6. And then no remainder, which is what we want. So everything is working out. So remainder, no x, x to the 1, x squared. So this is x squared minus x minus 6. So we're going to factor that. So the numbers that multiply to a -6 and add to a -1 are going to be a -3 and a +2. So x minus 3, x plus 2. And so we get x minus 3 is equal to 0. Move this over. X plus 2 is equal to 0. So x equals 3 and x equals -2. Alrighty. So my numbers are x equals 1, x equals 3, x equals 2. Alrighty. So again, you could do this via the calculator and see when it is less than 0. But since we're doing this all algebraically in this video to help us, I'm going to erase all this and I'm going to draw my number line. And because I have 3 zeros, I'm going to have 3 ticks. So 1, 2, 3. And so we should put them in order. Sorry, that's a -2. I believe it's -2, right? Yep, -2, 1, and 3. So put them in order. -2, 1, 3. Alrighty, so again, this part you should do in a calculator and make your life easier. So let's pick -6, I'm going to pick 0 because it's easy, 2 because it's in between, and then 6 for just easiness sake. But again, you can pick any set of numbers you want to. So you're going to plug those in here, and then the kicker is it's less than. Okay. Now, because it's less than or equal to means that we're going to have brackets in our answers, but we'll get to that in just a second. So -6 cubed minus 2 times -6 squared minus 5 times -6 plus 6. Now, the big kicker is that this is -216. So it's going to be really tough to come back from anything getting close to 0. But this is going to be 36 times 2, so that's going to be minus 72. It's getting even worse, so we can definitely say that because that's less than 0, this section is true. Okay, so we're going to say from -infinity to -2, and then I'm going to put a bracket there because it includes -2, and it goes to -infinity. Alrighty, so I'm going to erase this and try my next one, which would be 0. So 0 cubed minus 2 times 0 minus 5 times 0 plus 6. Now, I like picking zeros because I know that all this isn't going to do anything because it's just 0. So then it's just 6. So clearly that's not less than 0, so that's false. Alrighty, so let's look at this next section with 2. So 2 cubed minus 2 times 2 squared minus 5 times 2 plus 6, so this is 8, and then minus 8, minus 10, and then plus 6, so it's going to be a -4, so it's close, but it still works because it has to be negative. Alrighty, and then last but not least is this 6, so we're going to do 6 cubed minus 2 times 6 squared, 5 times 2 plus 6, so 216. Again, we're going to be tough to get to negative from there. So minus 72 minus 10 plus 6, that's clear to say that that's false. So the thing that I'm missing is this true section in here. So because it's in between these two zeros, we're going to say, okay, it's in between 1 and 3, and then brackets because it's or equal to with our union in between. Alrighty. So, ladies and gentlemen, boys and girls, we're doing great. So we have one last one here. All right, we finally reached our last one here, sports fans. Had a little, had to go to the bathroom, so I hit pause, and now I'm back here. It might be too much information, but we're at the last problem. So hey, you stuck through for 42 minutes. You're good. Alrighty, so it's very similar to the other ones. We are going to have our number lines to check things because it's an inequality, but I do need to solve it. So I'm going to pretend to solve it like it's equal to 0. So I'm going to put this over 1. So I get x minus 1 over x plus 4, and I'm going to put those in parentheses. And then equal to 2 over 1. And then I'm going to cross multiply. So that's going to give me 2 times x plus 4, which is 2x plus 8. And then cross multiply this way. And I'm going to get 1 times x minus 1, so that's going to be equal to x minus 1. Now we're just going to solve for x, so I'm going to move this x over and get x, move that over, get -9. So that's one of my values. The other one of our values that we're going to check is when this equals to 0. So x plus 4 is equal to 0, so x equals -4. So I have a couple of regions here to check. So I have two values. So we're going to go -9 and -4. Okay. So I'm going to test it. Again, plug it back in. So I'm going to try -10 because that's less than 9, a -5 because that's in between, and then 0 to make things easier. So let's test this -10 region, which is right here. So I have -10. Sorry, I got to go back and see what we had. -1 over 10 plus 4. And of course, that has to be bigger than 2. So -11 over a -6 is going to be 11 over 6. Okay, so that is super close, but it's not bigger than 2, so that's false. So let's try this middle region. So negative 5 minus 1, and then negative 5 plus 4. So that's going to give me negative 6 divided by a negative 1, which is 6. And that's definitely greater than 2, so this is going to be true. And then last but not least is our 0 region. So 0 minus 1 over 0 plus 4. So that's going to be negative 1/4, which is definitely not bigger than 2. So the only region that works is this blue one in here. So our answer is going to be from negative 9 to negative 4. And then I'm going to put in brackets because it's, if we look at the beginning here, it's or equal to. All right, my friends, this is the end of our video for chapter 2. Hopefully you found it helpful. You guys take care, and we'll see you next time.